So you, I'm sorry.
No, you go.
Well, I'm not a statistician, so you propose that the use of this self-weighted system to calculate self-weighted means and to understand your distribution is a better system than just using
definitely.
the typical arithmetic means with the normal curves.
Yeah, actually the arithmetic mean just suitable for standard, a typical normal distribution. It is squared. It is a biased estimate for squared distributions. However, if we take the self-weight to estimate the expectation for the squared distribution, we can find the real location, actual location of the centralized.
So your proposed system has to do not with normally distributed data, but with skewed data.
Actually, for example, in the microarray data analysis, we have to take thousands testing, right? We cannot determine each paired samples be compared are normal or non-normal. However, in the self-weighted mean, we don't need the assumption of normality. We don't need it. So we have a consistent measurement for the p-value calculation. Because the p-value calculation is a random measurement. We need a consistent measurement.
The expectations of Kolmogorov that you're rejecting, does he base his non-parametric statistics on?
In this way, if we take the self-weight, the non-parametric methodology may be give up. We don't need it, because we don't need the assumption of normality. We don't need it.
Okay, so well, in non-parametric statistics, normality is not assumed, right?
Yeah, yes, it is considered normality. If the normality cannot be satisfied, we have to take the non-parametric method. This is the current system.
Okay.
But however, if we take the self-weighted test, we don't need, everything is parametric. Everything is parametric.
You made some choices in that parameterization, though, like you're taking the squares and the quantities and you're looking at absolute value, their differences. I mean, why is it that those choices are better than other choices?
Oh.
Or choices that are less specific, you know? I mean,
I think this.
what I guess I'm getting at is that yours could be placed in this. Your approach could be put in the context of other more classical linear model approaches, like looking at the least squares estimate, which like an arithmetic means based on, and you should look at how those are different or similar in certain ways. I mean, I guess I don't understand what you're estimating when you in your distribution. Is it I mean, for a skewed distribution, because of the long tails, you would expect that the expected value is pulled away from that mode of that curve. But
actually, in my opinion, the mode is a concept defined because in the squared distributions, the arithmetical mean and the mode are separated from each other.
Right.
In the normal distribution, they are meet together. They are same. They are equal to each other.
And you want to be, it sounds like you want to have something that's robust to the fact that they may not be tied together like they are in a normal distribution or in a symmetric distribution. Like for say microarray data.
Yeah.
But I guess to gauge the properties and possible good properties of your estimator, I would say try to see how similar and how different it is from other. It is in some ways similar to it's a statistic, and you average a sum of statistics across all different things, and you get, it has large sample properties. In other words,
Yeah, we, how to say, I calculate that.
You calculate that, and that's, I guess
Large
that's sort of,
sample
yeah.
in this way. It's easy with SAS programming. In macro programming, it's easy in SAS.
I was thinking analytically though, like
Yeah.
just theoretically, what, you know.
As you can say, the self-weight for those points far from the expectation tends to 0. For those points and gathering around the expectation tends to larger. Yeah. So the self-weight gave us different measurement for the importance of each point to the expectation.
One obviously critical point that I missed is how do you determine self-weight?
Oh,
You discussed that, I didn't get it.
okay, let me show you. From here. The importance of a point, of a random point to the expectation is equal, it comes from its differentiality and the similarity to every other point. This,
Yeah, I understand the
Okay.
equations. I guess I don't understand the underlying thinking. Why is it more important because it's closer to the group? What makes that more important? Okay, so a given observation, if I understand the statement, is that given observation is more important, should have more weight, because it's closer to the mass of other observations in the group. Why does that make it more important?
I think, in my opinion, if a point is in the system, in a random system or not, determined by its differentialities and similarities to all the points in the system.
Okay, so that goes back to what you said earlier in your talk, where for something to be part of it, if something is uncorrelated with a system, then it's not part of the system. The higher its correlation with the overall system, the more it's part of that system, therefore more important and more weighted in that system.
Yeah.
This is what you're saying. So.
Yeah. Yeah. Actually, the relationship of a point to the others are calculated with their in their differentialities and similarities. We cannot either consider differentiality or similarity. We must consider both. This is dialectics. This is the dialectics.
And what?
Dialectics is a logic.
Well, dialectic is an evolution. So that
It's a logic. Dialectics is a logic. It means, it tells us.
it tells us that at each stage, we're led to the next stage by the interaction at that stage.
In different angle, we should consider or observing the objectives in different angles. In a in a complete system to observing the object. So actually, first I just think about the differentiality. When I was developing the methodology, I just think about the differentiation, and I found it's not enough. Then I go to the similarity. Then either way are not good. Either way are not good. So I have to combine it. Then I take the product of the cumulative similarity and the cumulative similarity. Then I have that curve, weighted curve. Otherwise I don't have. Yeah.
Start to get it.
Yeah, that's difficult. It's
I have a question. I have a comment. To develop a terminology, I think it's better to have a reference term. When you say a constant, that terminology to most people, either you're from what culture or what have you, that implies to me that it's not changing.
Yeah.
But for you, when you're saying a population constant or a variable constant, it doesn't seem to have the same terminology. Either you're from Western world or what I'm used to, thinking that a constant is a point that is not changing. So you may have to make a more classification or terminological weighing of what you mean by a constant in your terminologies, because it's so hard for me to always think that what you're saying is you're making like say I'm a biologist, so when you say a constant value in a biological term should be linear.
Okay.
So you may have to find a chance to show that if in fact your terminology can be true in biology or in physics or what have you, you may have to explain the terminology where it's being applied for, because obviously people like me will challenge you.
Yes.
If in fact you're saying...
Yeah, you are right. English is not my primary language.
Someone should be able to help you define the words, right words to do that.
Yeah, okay.
So like say you can say, instead of you saying constant, it may be something.
Actually, in my previous research paper, I have introduced the constant expectation, the concept of constant expectation, because in my opinion, the certainty is a part of the uncertainty. It's the beginning of the uncertainty. The uncertainty is starting from the certainty. So this is a continuous process. As in the digital system, we introduce zero. Zero means nothing, non-existence. So I try to introduce the constant into the random system, because the constant is no change. Yeah, no variability. It is the starting of the random system. I introduced the constant into the random system, just as someone introduced zero to the digital system. Yeah.
So there's still a reference.
Yeah. Yeah. Just because we have the constant, we can understand what is uncertainty, what is randomness, what is variability. If we don't have this one in the random system, we don't know what is the starting point, what is the end point. Yeah.
Because the way I see it is, at least in biology, it's better to have a chance to understand the chaos if in fact the power of your approach would be able to understand the interpretation of a chaos data in reference to a defined way for you to tell me a logic of constant either it be by computing or by analytical scheme where at least it gives you a handle of the chaotic values in the way you're showing. If you can show me that, I would be amazed. But at this point, it seems like it's so hard for me to make our position to appreciate the value of the power of the statistics unless it would be understood within the context of the variables, independent variables. I'm an independent variable the way I see it, but you're saying I'm a constant part.
Actually, the variability of attribute in my example, for example, the data set for coronary heart disease, the HDL, the name, this is the name of attribute. It is a variable due to the sub-attributes are different
I think it's
from
a
each other.
terminology. It's
Yeah.
terminology.
This is the, for me, this is the variability of the HDL. HDL is the random, is the random variable itself. You will take the random variable as the terminology.
But the values themselves.
The values are variable, but HDL, the name of the HDL itself, the name of the HDL itself is the variable.
Oh yeah, I
It's
mean
the
no one denies that.
we say the HDL is randomly variable because they are all sub attributes are different from each other randomly. Is this
I
help?
think, yeah,
Is
it
this
helps,
helpful?
but in the end, it would be nice.
In the current system, statistic, the first line of the name is meaningless. It's meaningless.
The first line of
The first line of the variable, the name of the variable, is meaningless. I cannot understand. Philosophically, I cannot understand.
It's hard to explain a chance to
They-
determine the power of an idea when you're talking a bit kind of very abstract, in the sense that for people that are visual or logical, they find it more easier if in fact you can show a data, let's say, either it be the way you have the mental picture and you may want to design an algorithm to determine the power of that concept, that's fine, but it would be nice if you can show the real interplay of, say, the different sensors of that system, so I can at least potentially see if in fact it's easy for me to translate that for biology or even for non-biology. I mean, this world is quite chaotic, but it should be understood in the sense that you flip the equation where it allows you to use a chance to interpret the variability of all what's be in that space to understand the power of your constant, your term. At this point, it's hard. It seems like for me to, I don't know. I mean, that's just my first opinion. I'm just telling you because I'm a bit open-minded, but I want to see. I don't know with everyone. I don't know if they're puzzled like me.
I think it would be very helpful if you spent more time showing the example and demonstrating a little bit more in detail how you would calculate it, and less time on the terminology.
Okay.
Because I don't even know if people really dispute some of the terminology, and maybe that's the case. In my field, epidemiology, everyone uses different terminology for everything. It makes very confusing situation. But sometimes everyone's actually just saying the same thing with different terminology.
Yeah.
So I don't know if you should spend so much time, especially at a presentation. I would spend more time with giving the example, giving the, the equations or whatever you're using to calculate these new methods, and then the example. I think
Yeah,
it would
and
be
then
very
design
helpful.
an algorithm as a proof to say, okay, this is a potential algorithm that it should be handled this kind of problem, either it be biology or chemical mapping or protein mapping or what have you. So
Actually, this is for calculation. This is a calculation framework with a tablet. The first column is the original variable, x. That's the only thing we have. Then we define the define the point-to-point differentiality and the point-to-point similarity. Then calculate the sum for differentialities and the similarities respectively. Then take the product of the cumulative similarities and the differentialities. Okay.
Thank you, Ligong.
Then,
Thank you for sharing that with us. Yes, I appreciate it.
then we relativize the product to 0, 1, to the range 0, 1. And this will give us a K curve. This is contradictory. So we have to take the opposite of this one.
Yeah, so you adjust the mechanism to correspond. You adjust your mechanism, mechanism, like your system. You adjust your analytic system to correspond to the population that you're interested to understand.
Mm-hmm.
Let me interject this. I'm especially interested in your work because what we study is epilepsy.
What?
Epilepsy.
Epilepsy.
Yeah. So epilepsy, that's the disease.
Disease.
Where someone periodically loses control of their body and shakes and becomes unconscious, falls down to the ground. Epilepsy. I don't know the genes. So
Do you have any?
is that clear?
Yeah.
What is epilepsy? Yeah, what is epilepsy? What, epilepsy, how do you say epilepsy? Yeah. In Chinese. Yan Jian? Just please tell Dr. Chen, please. Maybe you'll help me out.
Hello? What's the? Okay. I know. Okay. 谢谢. Thank you. I know that.
Okay. Thank you.
Yeah.
Fine.
Okay.
Okay, so this is something that starts out in a normal state and then evolves to a different state.
Yeah.
So in a sense it's dialectic.
Mm-hmm.
And in typical course, it also comes back around and it stops. It always stops. To record, so the data comes from an experimental condition with an animal.
Mm-hmm. So
the whole process is dialectic. It's continually evolving in that sense. And so I'm understanding that like you might be interested in looking at something like that and seeing how that evolves in the system.
Mm-hmm.
And because I do that, I'm interested in your system.
Okay. Yeah.
So
And you are a doctor, not a statistician.
yeah.
Okay. But you need statistics, right, to analyze your data. Yeah. This method is the most basic methodology for describe the sample. But based on this, we can develop a new high and advanced methodology. For example, differential testing, for example, t-test or ANOVA with the self-weight.
Oh.
Yeah.
Would I be able to get either your paper or your PowerPoint? So
yeah, I will present it at the joint statistical meetings at July 31. Then the complete paper will be published in the proceedings. Then you can cite it. Mostly it will be appeared in November. This November.
it'll appear printed.
Yeah, definitely. It will be actually, if you can, if you would like to cite it in a website, can you? Yeah, the whole methodology is on a website.
It's on your website.
No, yeah, meeting.
It's on
Yeah,
your-
meetings website.
Is it there now, or will it be after July?
Right now you can cite it.
Inside?
Yeah, you can cite it. Because the algorithms, the complete algorithm is appeared on a website.
Would you say again which website that is?
American Statistical Association. Why is I?
Algorithms, the American Statistical Society website.
Website. I can give you the website. Could you open the website? Fine.
Oh, it's just right.
Oh, the battery.
Maybe I can talk to Sandy for a reason.
I criticize the optimizations. So, my paper was rejected by many journals.
Yeah. When you do something original, I guess that's powerful.
It is accepted by the general methodology, the section of the general methodology in this meeting. It's, the algorithm is here. And you can control, which is control C. Okay. Then to okay, your document. What is your document? Okay. Yeah. And then you can bookmark it.
And so you give the algorithm,
Yeah.
and do you discuss the philosophic foundation? Is your paper there, or is
After this meeting, the
Okay.
paper will be
Yeah.
published in the proceedings.
in the proceedings?
In proceedings, yeah.
Okay.
Maybe I will seek to be published from a journal. Maybe. Yeah. But actually, in the proceedings, it can be cited. It's okay. The idea is definitely new,
Mhm.
and it's very fantastic.
Yes,
Yeah.
that is, I see that. I see. And in the paper that's going to come out in the proceedings,
Yeah, but
or in the journal, you spoke about it a lot in your PowerPoint, where you present the philosophical foundation in your paper.
yeah, we have two separate presentations at the meetings. One for the basic conceptions, the other is for this algorithms.
Okay. I would like to, okay, so when, so both of those will come out.
Both, yeah, both of them will be comes, yeah, into the proceedings, definitely. Because the basic conception, actually I have finished the paper
Mhm.
for the basic conceptions and submitted to a journal, to several journals. All of them rejected because they would like to follow the old subsystem.
Right.
Yeah, there's some criticism
Mhm.
in my paper. Yeah, to the current system. This is difficult. Yeah,
Sorry.
this is difficult. Many papers have been published with the self-weight defined in that way, just as I introduced.
Mhm.
Yeah, that's wrong.
Oh.
Yeah, that's wrong. They take the xi as the weight of the x. That's wrong. That's inappropriate.
You're working to correct.
So
that.
you can find, you can see some chaos
Mhm.
in statistics.
Somewhere.
Some chaos.
In statistics.
Yeah, in statistics. Many people propose their idea. And anyway, they propose a method, and then some are accepted, some are rejected.
That's right.
Yeah, even those accepted are incorrect. Statistics are general methodology. If the methodology is wrong, the conclusion will be wrong.
Yes.
Because your result is it comes from the methodology.
Yes. Simply.
Yeah. So, but a statistical methodology is not rooted in mathematics. It is rooted in philosophy. We must have everything, every idea is correct
Mhm.
first. Then your idea, the correct idea will be expressed in mathematics,
Yes.
in statistics.
Yes.
If your idea is incorrect, your mathematical expression, okay, mathematically is correct, but your idea is wrong.
Yeah. I understand that.
Yeah, so your methodology is wrong.
I understand that.
That's very important thing, but many people don't realize this.
maybe after I read your paper and understand better, maybe could I talk to you again?
Yeah, okay, sure. Actually, I would like to say the concepts developer I need are a preliminary concept, not an advanced one. But for those anyone has a high school education background can understand definitely.
That's the way it should be, isn't it? Because it's
It's
based
easy.
on philosophy
Yeah, it's
and
easy.
epistemology.
Yeah, yeah. It is not mathematical, but it's a preliminary system, not an advanced one. Make advanced one need more mathematical, yeah, stuff.
Yeah, it seems to make sense.
Yeah.
Okay, it's very
Okay.
good.
Yeah, thank you. Appreciate
Thank you very much.
coming. Yeah.
Thank you.
Okay.
I,
May I have your name or?
yeah, maybe I could, I can send an email. Could
Oh, okay.
maybe I'll send an email to you,
Okay. Okay.
just to make contact.
Do you have my email?
Well,
Is this?
I could look you up, of course.
Okay.
Maybe you can give me.
Okay. It's good.
Do you prefer this?
Anyway.
It does both.
Anyway. But I prefer the personal one.
You prefer the person?
Yeah, because the personal one is permanent.
I understand.
Maybe someday I need the users, I cannot access this.
I'll write to your personal.
Okay.
email.
Yeah, thank you.
Thank you very much.
Yeah, appreciate it.